Welcome back. Now let us do the hands-on on one class SVM and 185. Let us read the data fresh. And since one class SVM need basically one closed class, so let us see the first table of the dependent variable. And if you see that we have the three label over here and three labels and all have the equal number of records. So what we are going to do, since one class need one class, so and that closed class, let us say we are selecting Setosa and marking everything that is as a Setosa as a true and non-Setosa as a false. So basically this much 50 records will be true, and this 50 plus 50, 100 will be false. Okay, so let's us run the 189. So it has done that changes, and now if you see the table again, line 188, it will show you 250 and the false 100. So now we can build the model with any one of this class. Okay, and we have the categorical columns only one. Let us convert that to categorical column as a factor. And the line 195 to line 199 is the segregation in train and test. Train will be 85% and test will be around 15%. This is what. So we have 128 for the training and the 22 for testing. Okay, that is good, looking good. Now what we are doing, since for the training we need only one class, and let us start taking that train only one class. So whichever is having the true, let us start building. So this part is so line number 202. We are seeing at this moment it will have the both true and false, and for one class SVM we need only one class, so we are taking only one class, say taking true, and that is what our train is. So if you see that right now, train is having 128 observation and 5 variables. So I'm running 202. So after this it will become train 43 observation 5 variable, because all are true only. Now we have the species all variable only true. So there is no need of a species column at all, because all these values are only true. So let me print and show to you. So if you see, yes, see this is what everything is true. So no need to have the species at all. That is why dependent variable we are removing in line 203. One class SVM is available in library called E1071. So let us get that library. And 207 we are having the constant about the row number and column number. Okay, and these are the some of the default parameters. So what it says, new is 0.05, it means around 5%. So what it is saying that we are expecting 5% noise in the data. So algorithm will, if it will try to match with accuracy of 95%, and boundary 5% it will think as a error. Kernel, radial means this is the graph, that hyperplane. This hyperplane, that is what. So if you see the documentation of this one class SVM, it has the various kernel. We are going to use the radial. Radial is the curve, and this is the gamma. This is the few of the things required by this one, and you can see the detail in the documentation. Okay, and now we are running line 213 just to show that we are going to work with 43 rows and 4 columns. And line 214 is giving us the various parameters which will be using it. That's all. We are done with data preparation. Now 217 is for the building the SVM, and it is taking x, that is the train data, y equal to null because it is not required. New we have already defined over here, gamma we have defined above, and the kernel we have defined, cost we have defined, and type is one class SVM, because this can be used for a few other purpose also. So this SVM is the type is one class SVM and one classification, and scale false because we have already scaled the data, and fitted false basically don't fit, will fit again, will fit our own. Okay, so this line 217 is the building the model. I have just run it. Since we have the data hardly 43 rows, it will take hardly a second. It has done it. 218 we are saving the model. 219 we are cleaning up the data, and 222 getting the list of the predicted variables, and the 223 we are predicting on the test data directly. This time we are not doing the prediction on the train because I have already done previously long number of times, and here we are directly predicting the test one. So 223 is the prediction on the test one. So this is what the prediction. Let me show it to you. So if you see this when I print, for all this has given true false, true false, true false. Okay, so what it means that whichever is belonging to that closed group, it is true, else it is a false. Okay, and just to let you know, see, in case of R it is true and false. In case of Python, I think it is 1 and -1, and it may happen for the different technology this will be the different, but exactly it convey the same meaning. There is no difference. Now let us go and do the classification summary, where this prediction which we have just got and actual we have already over here. So let us do the classification summary. We are running it here, and when we saw it over here, it looks like it has done the perfect job. It means the diagonal is all the right one, and non-diagonal there is a 0. So accuracy is perfect, kappa is perfect, sensitivity is perfect, specificity is perfect. So it is good. But generally, in case of when you have the huge number of data, it may not be the perfect. And what is the not perfect? Say suppose it is giving you accuracy 95%. If like a 9% is good enough as per your business requirement, then definitely you are good to go. Else try to tune the various model and try to improve it. There are multiple ways through which you can clean up the data or you can improve the accuracy. That's all for one class SVM, and line 2 to 9 we are simply cleaning up. So that's all for the one class SVM, and if you find that this is also the similar to the other classification technique, and if you have any questions, please write the questions on the discussion board. I'll be happy to reply you. Thanks a lot for watching it. See you in the next one.